Hello and welcome back to another LeetCode problem. We're looking at 2657, find the prefix common array of two arrays. It's a medium problem. I have not tried this one myself before. Why am I looking at solutions? Let's look at the submissions. No submissions from me. And yeah, I'm going to try to solve it interview style, where we first read the problem, check the constraints, go through the examples to come up with an intuition of how a solution algorithm might look like, and then we'll give a space and time complexity analysis before we start implementing it. And yeah, and hopefully that'll work out just fine for us. So let's get started. You are given two zero-index integer permutations, a and b, of length n. The prefix common array of a and b is an array C such that Ci is equal to the current number that represents at or before the index I in both A and B. Wait, let me read that again. The prefix common array of A and B is an array C such that C at position I is equal to the count of numbers that are present at or before the index I in both arrays. So, okay. Return the prefix common array A and B. A sequence of n integers is called a permutation if it contains all integers from 1 to n exactly once. So we have two arrays. The two arrays have the same length. There's at least one element in each of those arrays. We have an upper bound, but that's irrelevant for us. This is only relevant for LeetCode, because if we took that upper bound, we could argue that our space and time complexity is going to be constant. Which is, of course, well, nonsense if we want to do a proper asymptotic runtime and space complexity analysis. And the values of the numbers in the arrays are between 1 and n. Cool. And n equals the length of each array as well. It is guaranteed that a and b are both a permutation of n integers. Okay, nice. So let's maybe step here through an example to understand it a little better. We have two arrays. They contain the same number of numbers, and they contain the same numbers but in different order. Okay, this is our output. So let's check. At index 0, no number is common. So, all right. That's because 1 is not the same as 3. At index 1, 1 and 3 are common in A and B. So C is 2. 1 and 3 are both exist in both arrays. So okay, so C is 2. So I guess we're counting the number of common elements. A prefix common array of A and B is an array such that is equal to the count of numbers that are present in both. Okay, yeah. So we're counting the number of common elements in A and B up to index I. Now up to index 2, let's do it ourselves. Now we add the 3, so that means the C should be 3, the count. And then when we have the full length of the array, that means we need to insert n, because now we're guaranteed that all numbers in there, so it's 4. Interesting. Okay, let's do one more example. So, and let's try to do this without looking at the solution. So we have 1, 2, and 3 in the array. Array 1, so this is 0. Now we have 1 the same, which is the value 3 is in both at index 1. And then at index 3, all of this are the same. Yeah, so that's that. Yes. I see. Well, I think we can exploit the fact that we know what the numbers in the arrays are, and that they're all consecutive, and that they are between 1 and the length of the array. So what we could do is, we could keep maybe a set of all the numbers. That would be O of n time. And each time, well, maybe we should keep a hash map. And in the hash map, we increase its value by 1 if we find an element in 1. So let's say we counter 1 in array A. That means the hash map for key 1 is going to be +1. And as soon as we encounter an element in B, that means we're going to reduce the count of that key 3 by -1. And only when they annihilate each other, we know that now this number is in both areas up at index I. Yes, so we could create a hash map that has size n, and then we just remove elements from it as we iterate through the areas A and B. And maybe we should say that in the beginning the value is 2 for all the elements in the hash map, then just we reduce them, and once we've reduced them twice, so reduce them once for area A, reduce them once for occurrence in area B, and then when 0, we just delete it. And we can use the length, well, n minus the length of our hash map to put that into our result dictionary. So I think that would work just fine. So we would get a linear time, linear space algorithm that way. And maybe there's a way to do it without the hash map, but I don't think, maybe there is a way, but I'm not sure. I think I would just like to implement the solution that I just came up with. So let's just do this O of n time, time and space. And then we just iterate. Well, we need to iterate over all of the elements, but also we need to have a little hash map. So we have our, we call this counter, and that's going to be well, our dictionary. So we have put n in it, and we'll put the value 2 in it. And for n in range 1, 2, 1 plus length a. And length a is the same as length b. Right, so now we iterate over all our indices for I in range length a. And we'll do this counter at a for key I at position a minus equals 1. And we do the same for the number that we get from b. Now we need to do a little check. If that counter is equal to 0, we're just going to delete it. That's what we'll do. And we'll do the same for the second case, like so. And we're doing it separately instead of afterwards, because if a and b point to the exact same number, we'll reduce it twice to 0. That's fine. But then we'll delete it, and then we try to access it, which will return us an error. So we check after reducing it, and if that reduces it to 0, that means that this one cannot be the same number as AI. Yeah. And okay. And next, what we'll do, well, we need our little result array, I guess. And we're just going to append the n minus, and maybe we should, we'll just do it like this. Length of a minus our length of our counter hash map. So in the beginning, if there are no matches, we will actually put in 0 because the counter has as many elements as the length of the array. And finally, when we've iterated through all elements in the last step, we're guaranteed that we have no more elements in counter. So we will actually put in the length of the array, which is exactly what we observed here. Right. So that should be right. Yeah, and I'm pretty confident that this will work. I'm not even going to bother going through the code. I'm also impatient. In an interview, I would do that. But here I was pretty confident. So those two cases pass. And I would now submit this to see if it works. Oh yeah, and it works. Nice. I don't know why this is here. Maybe it should be nice. Your UI. Okay, cool. So that works. Very nice. Let's see if anybody else has faster solutions. We're going to look at Python ones. O of n. Solution counting. Oh yeah, you could also use a counting solution. Let me just have a look at this. So this creates This creates an array instead of a hash map, and then, you know, you keep track of the counts in there. But then finally, you also have to check the count. So this is actually O of, why is this O of n, not O of n squared? The check count takes O of n time. The for loop in which check count is called takes O of n. So this is actually O of n squared, not O of n. But I agree that the space complexity is O of n. So that solution is not and O of n memory. So we have that. Simplified counter. Okay, there's some genius is striking with a bit map masking again. I don't know if you need to be able to do that in an interview. I don't know. I probably wouldn't do it. And it's also doing some trickery. If you start to work with bit masking, you probably have to exploit constraints on the number of different values you can have in the array. And then that already also means that you have a constraint on how long those arrays can be, because all the elements are supposed to be different. Let me see. Yeah, I don't know. So anyways, I think we have a good solution. I think that's good enough. So recommend to try to implement this yourself. Maybe test out the other way to do it with a fixed array instead of a hash map. Yeah.